So in this video, we're going to be looking at structural formula. Now, structural formula is a formula where we show the minimal amount of detail for the arrangement of atoms in a molecule. Now, let's say if I were to deal with something like pentane, which you can see over here, I've got the formula of C5H12. There's a molecular formula. Well, the thing is, that doesn't actually tell me that this molecule is going to be pentane, because it could actually be something like 2-methylbutane. Now, without actually drawing the displayed formula out or the skeletal formula, you can actually write something called a structural formula, where we look at each individual carbon environment. So in this case, I've got 1, 2, 3, 4, and 5 carbon atoms over here, and you actually show what's actually attached to each carbon atom. Now, let's say if I were to do this one, I would look at the first carbon atom over here, and I would have 1, 2, 3 hydrogen atoms attached over here. So I know I end up with CH3 to start off my structural formula. The next thing is of course, I've got the second carbon atom here with 2 hydrogen atoms there, so I end up with CH2 next. Now you can see here that this first carbon atom is bonded to 3 hydrogen atoms, and then of course it's also bonded to the carbon atom over here. Now if I continue this, I end up with the third carbon atom being CH2, the fourth carbon atom being CH2, and at the end of the chain, the fifth carbon atom is going to have 1, 2, 3 hydrogens, and so we end up with CH3 itself. And that's how I can show the formula for pentane, the structural formula for pentane, which gives me the minimal detail without drawing every single bond on there. Or about another example where we're dealing with, of course, something like an alcohol, propan-1-ol. Well, how do I actually know this is propan-1-ol without drawing out the displayed formula, without actually naming it? Well, what I can actually do is write the structural formula where I look at each and every single carbon atom over here. You can see, of course, we've also got an alcohol functional group at the end over here, and if you ever see something like this at the end, we would always write it out at the end as well. So yeah, if I were to look at each carbon atom, I've got over here CH3 to begin with, because I've got 1, 2, 3 hydrogen atoms over here. I've also got 2 hydrogen atoms in this next one over here, so I've got CH2 in this case. I look at the third carbon atom over here, and I can see, of course, I've got 2 hydrogen atoms around it, so I end up with CH2. But of course, that's 3 bonds to this carbon atom so far, 2 to the hydrogen, 1 each, and then we end up with, of course, 1 to this carbon atom over here. But we've also got here an alcohol group. Now what I suggest is if you were to deal with this, because technically it's going to be at the first position, that's why it's called propan-1-ol. If you were to deal with this, you would deal with it back to front, and you would end up adding, of course, your OH at the end over here. So you know that carbon atom over here is going to be bonded to this oxygen over here as well. And that's an easy way of actually writing out the structural formula for something like propan-1-ol. And you can see here we've got the structure clearly drawn out compared to, of course, our molecular formula over here. Now let's say if we were to go about this from right to left, because either way is fine, you're still going to end up with the same name. It's still going to be propan-1-ol. You still actually name it from right to left in this case, in how it's drawn in this displayed formula over here. If I were to do it the proper way, where I say that's carbon atom 1, that's 2, and that's 3, I could also end up with CH in this case, and it's going to be 2 because I've got 2 hydrogens. But then I'm going to end up with OH itself like this, and then I'm going to end up with CH2 and then CH3 itself. Now the thing is, right, that OH kind of looks confusing. To show that we've actually got this oxygen bonded to the carbon on this one over here, we're going to put some brackets around it itself. So if we're dealing with a functional group or any type of group like a branch, that's going to be in the middle of the chain, or that's going to be in the middle of our structural formula, we just put some brackets around it, so we end up with something that looks like that. So yeah, if I were to clean that up, I would end up with, of course, the following structure over here, and either one of these two, they're going to be accepted. But of course, I actually prefer this top one over here, just because it's easier to actually draw our functional group at the end. Right, if you've got it at the end or at the start, you can just flip it and you can draw it at the end. Now in some cases you might be dealing with big, massive, long structures with repetitive CH2 groups, like in something like decane, right, that's got 10 carbon atoms. You'll end up with 1 CH3 at one side, another CH3 at another side, and you'll end up with 8 lots of CH2 itself. Now what you can actually do is you can actually shorten this down, so you end up with CH3 like that on one side, and then you're going to end up with, in brackets, CH2, and you're going to end up with 8 lots of CH2 and then end it in CH3. Now I would advise that you don't do this, just because it can get quite confusing for the examiner, but you do need to be able to interpret it instead. So yeah, there's two examples there on how we can actually shorten structural formula just to save ourselves a bit of time in the exam. Now there's two rules that you need to be aware of. If we're dealing with functional groups on the end carbon atom, we would need to actually put these on the end carbon atom on either the start or at the end, and I prefer to go with it at the end. We can actually write it out backwards compared to how we would actually name it. Now another rule is if we're actually dealing with more than one atom in a group and we've got that not at the end, we would normally use something like brackets to actually show that. And we've already done this in our previous example with the actual alcohol itself. So again, we look at propan-1-ol, we could end up with, of course, CH3, CH2, and then we could end up with CH2OH. And you can see here it's at the end, the OH is at the end. But then what about if I was dealing with something like butan-2-ol, where that OH is no longer at the end? We would end up with CH3, CH, and then it's going to be, of course, brackets OH, because that's bonded to this carbon atom over here. And then we would end up with CH2, and we would end it in CH3. Now that OH could have been on this carbon atom as well over here. It's just going to be flipped, but of course it's going to be very similar and it's quite easy to see. So yeah, there's our alcohols kind of done there. If we were to look at our next one, we've got an aldehyde over here, propanal. Now again, we're going to end up with 3 carbon atoms, so I'm going to end up with CH3, we end up with, of course, CH2, and then at the end we're going to end up with C. It's going to be double bonded to an oxygen, but we don't need to show that. We show the hydrogen like this, and then of course we end up with an oxygen there. That's to show us that we've got carbon double bonded to an oxygen, and that's going to be bonded to a hydrogen as well. And there's that functional group done. Now what about if I'm dealing with something that contains, of course, one atom in its functional group, like a haloalkane? Well, in this case, right, again, we're going to have 3 carbon atoms, so it's going to be CH3, CH2, but then remember, one of those hydrogens is going to be swapped out for a chlorine. We end up with, of course, a chlorine over here. We don't need brackets because it's not that confusing, because of course we only use brackets if we've got more than one atom in our functional group to show that that is the functional group. And then of course, if I were to end this off, I would end up with CH3 at the end. And you can kind of see here that if we're at the end of the chain, we do have a CH3 there because that carbon is not bonded to any more further carbons itself. Now looking at the next one, we're actually dealing with an alkene over here. And let's say if I were to deal with pentwanine, right, pentwanine is going to have an alkene at the 1 position. So we know rather than having CH3, instead we're going to have CH2, because remember, we've got a double bond in there and we need to show that double bond in our structure. That's going to be bonded to a carbon atom, that's bonded to a hydrogen, and then we're going to end up with, of course, our remaining kind of carbon chain. So we end up with CH2 after that, another CH2 there, that's 4 carbon atoms, and then we end it in CH3. Now that double bond that we have over there, make sure that these carbon atoms over here, they actually have 1 less hydrogen atom than they would do normally. And to be more clear, that is actually a 2 over there, but it's quite hard to see. But yeah, look at the next one. We've got a branch in this case. So we've got pentane, but 3 methyl pentane. So we know on the 3rd carbon atom, we're going to end up with a CH3. So I would go about this one by putting CH3, CH2, and then of course on the 3rd carbon atom I'm going to have C, and then I'm going to have, of course, my hydrogen next, but one of the hydrogens has been swapped out for a methyl group. Now this methyl group over here, because of course it's going to contain more than one atom for a functional group, in this case it's going to be a branch, we're going to end up with this in brackets so that we don't actually get confused and we don't confuse the examiner or whoever we're drawing the structural formula for. Again, after that we're going to end up with our CH2 again, and then we end up with CH3 itself. Now you can see I've got my total number of carbon atoms being 1, 2, 3. There's my branch, then we've got 4 and then 5. That's the 6th carbon atom over here. That's going to be, of course, our branch. So if we were to look at the next one, we've got ethanoic acid. This one's an easy one from GCSE. We've got CH3 and then a carboxylic acid. We would put OOH itself to get that one right. Look at the next one. We've got butanol. In this case, we've got a ketone. Doesn't matter what position it's at, because remember, it can't be at the end. It can only be not at the end, and we can only get it in the 2 position for butanol. So in this case, right, we would actually end up with carbon. That's going to be bonded to 3 hydrogens. Then we end up with CH CH2, and you can actually have your ketone on this position, but I'm not going to. We have a carbon oxygen double bond that I'm going to show quite clearly over here, and then we end up with a CH3 at the end. Now of course these two over here could have swapped places, doesn't really matter, but there's a ketone done. What about the next one? We've got 1-bromopropane, we end up with CH3 in this case, CH2, this one's quite easy compared to 2-chloropropane. We're going to end up with CH2 over here because one of the hydrogens, they're swapped out for the actual bromine itself. Now of course you could flip that around where you end up with CH2, Br, CH2, and then CH3. Either one is going to be fine. If you've got here a butyrene molecule, we're going to deal with, of course, our alkene again. So we end up with CH3, then we end up with CH double bond, and then it's going to be to another carbon atom, another hydrogen there, and then we end up with CH3 at the end. If you are struggling, you can actually draw the displayed formula out first, and then you can actually look at each carbon environment. So yeah, looking at the task then, I want you to pause the video, have a go at the following, resume once you're ready to go over the answers. So yeah, going over these then, you're asked for the structural formula in this case. So you've got to use structural formula, nothing else, of the following. So for, let's say, A, 2-bromopropane, you're going to have CH3 to begin with, and then you're going to end up with, of course, CH, but then one of the hydrogens, remember, is swapped out for a bromine, so you end up with the following over here as well. Look at the next one. You've got 2,2-dimethyl butane, so you know you're going to have CH3, and then you're going to end up with carbon, and then, of course, you're going to end up with 2 CH3 groups this time, so you end up with something that looks like that, and then you're going to end up with, of course, your CH2 and then another CH3 itself to end it. And of course you can see you've got carbon 1, carbon 2, carbon 3 and carbon 4 there. That's that example done. The next one, you've got 1,2-dichloropropane. You can go about this two ways in this case, just like the last one where you could have had, of course, these CH3s here swapped out for these two hydrogens there. You can actually end up with here CH3, CH, and then of course Cl, and then of course CH2Cl itself. That's one answer, but you could have done it the other way around where you end up with CH2, Cl, and then CH, and then Cl, and then CH3 itself. Either one of these two, they're going to be fine. The next one, you've got 2-hydroxypropanoic acid. Now, first of all, you've got 3 carbon atoms on there. At the second position, though, remember, you've got an alcohol there. On the last position, you've got a carboxylic acid, which looks like this. So you're going to end up with CH3. That's your first carbon atom from the left, of course, to the actual right, where I'm going to focus on my carboxylic acid being on the right-hand side. Then you end up with, of course, CH, and then it's going to be OH in brackets because it's more than one atom, and then you end up with COOH itself as well. Looking at the next question, we're asked to systematically name the following compounds using IUPAC nomenclature. Now I would always draw these out just because some of them are quite messy, and I'm going to draw them out in terms of skeletal formula. Now what I like to do is of course number my carbon atoms in the main chain, excluding any branches, which technically that's wrong what I've just said, but we just go with it anyway because it's easier to actually draw out this way. So I look at it, I've got 2 carbon atoms that looks like this over here. I'm going to end up with 3 methyl groups on this first one, so I end up with 1, 2, and then 3 itself. I end up with, of course, an OH on this hydroxide over here, so that's carbon 1, carbon 2, and now we can draw the structure out like this. You can use displayed formula as well, but then you're going to name it. So in this case, you can see over here, if I were to follow IUPAC nomenclature, I end up with 1, 2, 3 carbon atoms, a branch here, a branch there. Position 1, I've also got an alcohol over here. So in this case, I'm going to say I've got 2, 2, and it's going to be dimethyl, and then it's going to be propan because that's the longest carbon chain, and then 1 ol itself, and there's that one done. So yeah, nice easy example. You need to get comfortable with this, and I would recommend that you practice as many as you can because it comes up quite often in the alkenes and the alcohols topic. Look at the next one. You've got, of course, a carbon atom over here. We'll say that's 1. We're going to say that, of course, this one's 2, and we can see we've got here an aldehyde functional group. So in that case, I end up with, of course, 1, 2 carbon atoms that looks like this. I end up with my aldehyde functional group there as well. But remember, you've got 2 methyl groups there, so I'm going to end up with 1 this way and 1 that way, and now you would just name it as normal. So you end up with carbon 1, carbon 2, carbon 3. You got a methyl there, aldehyde over there. So how would you actually name this? Well, I'm going to say that this is going to be 2, and it's going to be methyl, that's a prefix, and then I'm going to call it, of course, propanol, because it's going to be an aldehyde. So yeah, there's our answer for that one. Nice, easy, another example there, done. Now of course the examiner actually gives it to you in this weird way, and you've got to find the structure and then of course name it using that as well, and you've got to get used to it because it is very common in exams.